Alright, hello. We're back at it again. So, last time we got the bindings to work. And yeah, that was a huge hurdle. Although the kind of the issues are probably gonna keep coming, but that was a huge hurdle that we solved with being able to reference things outside of, so basically cross thread here. And now, so it works well for, you know, constants here, but now we want to tackle mutables, and this is not even like, well, if we run this, it works. You can declare a mutable. However, I think what's happening is that it's basically the same as a constant right now. There are no like instructions spawned from this, which there should be, because what I'm thinking is that it should be stored in the heap somewhere. Now traditionally, if you compare to like C, this variable would be stored in like a stack. It would be stored on the stack, and then whenever it's referenced, it would use that stack address to refer to it. However, we can't really do that, as I've discovered, is because, well, I mean, yeah, there are some quirks to this. Like, let's say, because it's kind of like the main thread is running here, right? And so whenever the main thread is like exiting, then the main thread stack becomes invalidated. So whatever variable we're declaring over here, now let's say we spawn, now we don't really have this feature, but let's say we spawn this in the background, right? And that refers to X. Like after this statement, the main thread exits and this becomes invalidated if it's on the stack, because the stack gets like deleted basically. And then what happens with this X? So there's a race condition there. So if this X is like, well, it doesn't really matter. Let's say we sleep 1 second and then try to echo X. You know, that would be some kind of, that would be like we're trying to access this X, but it's invalidated, so it doesn't exist anymore, and that's an issue. So I think what we're gonna do is we're simply gonna, instead of using the stack, we're gonna use the closure. So we're gonna store all the local variables on the closure instead, unless it's a constant, in which case we don't really store it anywhere. But if it's a mutable, we add it to our closure, I believe. So yeah, and that's, we have a mechanism to do that right now. So let's start there, and let's go to the compiler and to compile binding declaration, compile binding. All right, so here is like, we're binding an identifier to something, and we don't really care about mutability at this point. We don't really do anything with that. The thing is, we're gonna say if, so what is supposed to happen here? Like, because this part here is when we so this part here is like if we try to bind something to like an executable result. That's also something that I haven't tried actually, is doing this. So let's say this echo hello, hello from binding, and we echo that out. Okay. Okay, we have an issue here as well because this this just executes this in. Okay, so we have an issue there as well. Okay, but that is a different issue. I will write this down in to do here. So basically, mutable. I mean, we need mutable variables overall to work, not just enclosures, and then also binding to executable calls. All right, or anything really. You can also do like this as well. Technically, you can bind to a block, and then the result of this would be stored in B. But we'll tackle that as we go along here. All right, so let's go back to here. So what should happen here is basically we want to store this on the heap. So we're going to allocate 1. We're going to... I'm just also eating here at the same time. But no. We're not allocating 1. What we're doing is we're gonna declare this. We're gonna declare this on the heap or on the closure. That's what we're gonna do. So that is gonna be stored on the closure. So that's gonna be added to the list of closure variables. And then the thing is, like at the end, the main thread will kind of insert those closure things, just like we're doing it with the threads. So we have to go to compile initial, and let's see the closure. See, we're not really creating the closure here. Create. Yeah, so we need to create the closure. So this will create like the refs. So 2 refs. There we go. And then, yeah. And then, so that's initial. So that is, so actually this would return the closure context. Okay. So this is the main thread's closure. And after we're done with everything, before exit, we will do compile closure initialization. Source is null. Closure is main closure. All right. So now we have the ability. So now we have a closure in the main thread as well. So we have the ability to add variables to it, and then this would take care of initializing those at the end. I just need to do like edit type on this one. Hello, Subedara, welcome back. Hello, sorry, here it's every day, but I just came back from school. There was so much math in school. I'm glad I'm home now. By the way, still making a compiler. So, what am I hearing every day? No worries. How was school? Much math. So your brain is fried now. Yes, I'm making the compiler. I'm probably gonna do that for a while. Although I've been thinking about, I've been trying to get back into the game development and getting inspiration there. The problem is, I need more inspiration to what I actually do next. What to actually do next? That sounded weird. And then I will maybe do like a 1 week of this and then 1 week of the other project, or you know, whatever I feel like at the time. I'm not sure really, but I really want to make this work because I think it's so much fun to build this, and it feels like we're so close to kind of leveling out on a plateau where all the difficult parts are done, so now it's just a breeze to add the more easy things. Logs and algebra. I love math, but that is not this much. Everything has a limit. Game development, yeah, because I started this streaming thing. I actually started out with game development, but right now I took like a break from it and started with this project. But I do plan to get back to it. At some point. Okay. Cool. So. You're right. By the way, I just reached 54 subs by coding. Oh wow! Grats! That's awesome. What are you coding on the channel? Okay, so we have the closure. Now we need to go to our binding, and we need to now declare if it's mutable. We need to declare it in the closure. So I think that this works fine if it's not mutable. So I will do two different branches here. I will do if is mutable. If it's mutable, we'll do something. Otherwise, we'll do whatever we're doing here. Okay. If it's mutable, we'll do declare closure. in the current scope. Yeah, this is done. So awesome. Yeah, because we're declaring it in our current scope. So we're not looking at the previous scope or anything. We're declaring it in our current scope. All right. And what this does is that it will actually declare the variable in the scope as well. It will create a location. It will add it to the closure and then return the location. So yeah, so then I think we just simply return this. And it is mutable, so this is always true. New zig feature discovered. C was null while zig has null. Yeah, C null, isn't that just like kind of like a defined null is 0? Like that is part of like the libraries. And then zig has null, but the null in zig is a little bit different. But it's I guess it's kind of the same, but it's also pretty different as well. Like it doesn't just equal 0. It has a special value that and also the optional type in zig has like built-in syntax support, so that you can do things like, you know, const b is, let's say this is an optional usize. So even in the type you declare something to be optional and then null. You can't just say anything is null. That doesn't work. Yeah, so it is a little bit different. I would say the zig is probably a lot better, like a lot safer. Making terminal RPG in C programming language. Oh, nice. I'm willing to switch to zig after this project. Nice. We'll make combat today. Right. Awesome. I hope that goes well for you. What like terminal? Are you using any kind of terminal library for it, or expert programming, typing speed and accuracy montage? Oh, cool. Alright, so this would be like from, so you get a location there. Okay. Oh, hang on. This is the mutable. Yeah, so we don't actually need to return this. We just return void at the end, because this is like a statement that doesn't really, you can't use it as an expression. So yeah, it's just gonna be void there, because you're not gonna be able to create new variables inside another expression unless it's like a block. Well, at least for now. That might change later. Okay, standard IONC. So is it like is it like a roguelike, or is it a like a text-based adventure that, like, you know, prints like you know, like those old text adventure games? Alright, yeah, and we don't care about this result because it's already declared in here, so it's already, we don't care about it. Okay, now if it uses the R register, what happens then? Let's think about this. So this just declares the variable. Right. And this, yeah, it declares it. So we need to set it as well, I guess. So that we would get this closure location. And we would say, okay, well, let's set the closure location to, because it's already dereferenced. Yeah. So we'll set that to be, I guess we can add dereference here just to make sure. And what would that be? That would be the result. And when we do this, we don't mess with, I don't think we're messing with anything here actually. No, this doesn't even do any instructions or anything. So actually, we can just set this to result directly. Yeah. So now we have it, now we have the thing in the closure. So if we now go here and run this, it should work, but it doesn't. Okay. Attempt to use a null value. Okay. Well, actually, oh, wait. Hang on. Compile initial. It has a map and will have combat, inventory, and enemy system. Those text-based ones are a little too easy for me, so I thought I'd take up a challenge. Okay, so are you using like how are you rendering like the different parts? Like, are you using like ANSI codes or like directly? So you're not using any kind of library, or does the standard lib have utilities for that? Will you rewrite this in Rust? No. Just asking because of the meme of Rust programmers. Okay, yeah. No, I won't. I will probably never write anything in Rust. Because we have Zig. There's no reason to use Rust when you have Zig, right? Yo, Vincent, welcome back. The other day I learned that OpenTUI exists. Oh. OpenTUI. What is that written in? TypeScript. And Zig. 30% Zig. Astro. MDX, CSS. Okay. So how would you use it? Well, it's a TypeScript library. It would be cool if there could be like you could create bindings for a TypeScript library. You must have Zig installed on your system to build the packages. That's strange. Like, it's a TypeScript library that requires Zig. Wow. Are they using Zig? Like, why? Like, they use the solid front end. The open code framework. Okay, these are things that I don't know what it is. So here it is, OpenTUI. I think this is the thing anyway. Awesome. Built-in tree-sitter integration. Wow. That's actually useful, although I don't use TypeScript though, so... But I mean, we could... No. React and Solid.js. Oh, the Solid.js. Oh, I see. Wow. Okay, I've never actually used Solid.js, so I feel a little bit behind on that, but... Animations? What the hell? This looks like pixel animations. That's weird. But what I was interested in is like, yeah, there's 30% Zig, and you have to build it with Zig. I think it said. Where was it? Yeah, you must have Zig installed. So you need Bun and Zig. Like, okay. Where's the Zig stuff? And why? Huh. Okay, anyway, that is interesting. Okay. All right, let's let's see it. So okay, what did we do here? Oh yeah, panic. Attempt to use a null value compiler 12. So. Alright, it's when we're trying to do this. We're looking up the name in the declaration and we can't find it. Initial depth is 1. So, yeah, okay. Oh, okay. I see. So this is kind of weird. It's like the depth depends on how, like, if it's a mutable variable, it should, like, because the closure is kind of like used as a yeah, it's looking at the parent. But now when we have mutables, I was kind of hoping to piggyback on the closure, but when we create the instructions to so we're populating the closure here, so we're setting the closure basically here, add I, and the source, we're looking at the parent scope. And for mutable variables, we actually want to look at the current scope. I'm just going to grab my coffee, be right back. Okay, so but we don't really have a way to do that right now. I think, well, I guess we could populate the closure. Like we could actually. Why am I not getting this? Okay, so instead of this just being an identifier, I think we could include more things in here. We could say the type of variable, I guess, as well. So this would be like a closure binding. Which would have a identifier and I guess it would be like a type. We could also just say depth. All right. Now we should get some errors here. So when we declare that depth is used to get the frame where we declare the closure in, but then we want to have the source depth. That is actually, let's do like a closure, let's do like a binding here so we get the whole thing. Yeah, we'll just do this. All right. And the depth is actually going to be now depth. Okay, so here, compile identifier. So okay, so if it doesn't exist yet, that means it is from the outer scope. So this will always be grabbed from the outer scope. So this would be so let's actually do let's do like outer, and then we will depth 1. And then identifier. Okay, and then we would get from the current scope and there will be 0. Identifier. All right. Oh, this is also wait. Okay. So here we go. Compile identifier. So this would be outer. And then this would be the same. I think, yeah, if it doesn't exist, it will always be from the outer, yeah. Because if it's mutable, we actually define it directly when it's declared. So if we compile that identifier referring to a mutable variable in the same scope later on, we will already have it in the scope. So we wouldn't get that issue. So, but this one is now current. What did it say? Okay. Okay. So now, when we create the closure instructions, it will look at the correct depth. All right, we got another error. Unsupported dereference value type. Oops. Okay, let's actually let's do this because there could be different things happening here. So let's step through this. Wait, where's the forks? Oh, we're creating the closure first. Okay, yeah. And here we can see that, yeah, we save R. It's there's nothing there right now. We're allocating the closure for the main thread, and we are setting the first element to be closure +0. That does not seem correct. Yeah. Because we don't have a closure yet, that's the thing. Okay, what is it that it should be doing? It should be setting that to the result, right? The problem is though that this result is like, we could have another thing down here which depends on X, but the problem is that these variables are declared like at the top. I guess at the point of where this is declared, we actually set them directly there as well. So that will be set later. And in that case, oops. When we do this, because C plus 0 doesn't actually point to anything. So the closure, actually also this is wrong here. I just realized I need to, it was hard coded to be null. I'm just gonna go to evaluator forward. Yeah, this is hard coded to null. How did we do this? Okay, we actually need, I think what we do is we actually need to, whoops, add a thing here. The same way fork instruction has a receives a pointer to closure. Yeah. So this would be the closure address that we can add here. Well, actually, no, yeah, it's a location, yeah. It would be closure to address with context, thread, oops. No, wait. You're a value. Wait, how do we do this with the fork? Fork. All right, resolve location. Okay. There we go. Okay, now we need to add that here. You need the closure, so actually we want to do this kind of up here, and that is the location is that. I just want to check if it needs to be dereferenced. I think so, yes. There we go. Alright, now we have a proper space for that, so let's check this now. Wait, wait, what the hell? The forward standard IO thing disappeared for some reason. What? Yo, potatoes way better than tomato. What's going on? Making a Bash-like scripting language. Right now we're working on the what is it? Yeah, I'm working on making the mutable variables work, and in the process of that I'm currently adding like so this is running like a virtual machine, you could say, which has a heap. And so I'm currently adding a space for the mutable variables on the kind of heap in there. Well, thank you for subscribing. Are you a developer as well? But I think, yeah, this should be done first. And then we have the closure. What is going on? Why don't we have the instruction? Oh, because this is compiled first. Okay, yeah, that does make sense. That does make sense. Yes, yes, yes. Okay, okay. So we don't actually have the stack yet, but it still doesn't really make sense because this is gonna fail here. Yeah. So actually, we'll do this after standard forward. Yeah. All right. Right now it's. But now there's a problem because the closure is actually stored on stack number 0. Okay, maybe we just need a separate instruction for this. The closure maybe, or this instruction is probably not good for this, maybe. We need the... Wait, how do we do it with the fork? I don't remember. Because we always create the thing before. Yeah, okay. I think I see what's going on. So basically, this instruction creates... the streaming threads, and that will increase this by 3. But then we have the closure created here. No, I want this to be 4 or 3. Oh my god. I'm confusing myself. Should I use a UI-based library for my project or stick to TUI? I mean, I don't think I can really answer that question. It's up to you. What? But you could ask yourself. Like, would you require it to be a UI-based library? Like, what would be the reasons to switch for you? So I was waiting for like render the map like the first, print the whole map with the player, then there was an input, clear the screen and print with updated positions. Okay. Right, but clearing the screen, is that, are you using like a standard library function for that, or I'm not that familiar with what exists in the scene standard library, but or are you using like an ANSI code or something for that? Oh my god, what's going on? Okay. So I'm thinking of splitting this into separate things. I just trying to wrap my head around what's going on here. Because let's say we don't actually provide the closure here. Well, the thing is, the closure works like this. It's basically, it's stored on the heap, right? But then there's also an address that goes on the stack that always points to the current thread's closure. And that is what we are doing here, kind of. So we're compiling the create closure here. However, this is done in a very specific way. It's actually supposed to be using, it's custom tailored to be running with forks, or to work with fork instructions. So maybe this wasn't such a good idea after all. But basically we want to create these two refs. And then it's like when we do this, it surrounds the fork instruction with some instructions. But the problem is this is not a fork instruction anymore. This is the forward standard IO instruction. And we actually want this to happen after that. So we kind of want a different style of this that would do the same thing, except it's for the main thread. So I'm gonna say like main closure. And we don't care about OR. We do want the alloc. We're setting that to R. We're setting the closure variables. We don't have a saved R, so we don't care about this. And then this, we don't really have a thing that we surround. And I don't think we need to do any of this. Okay, so basically it's just we're just inserting the allocation of the heap or of the closure, depending on how much we need. And then we set the reference to that so that the stack, the closure ref on the stack will point to the allocated closure on the heap, and then we populate the closure. But the problem is when we populate it, we do like a lookup. Okay, actually here it's an issue as well. So when we populate the closure, if it's like a mutable, so this works good if you have like constant, or if it's a closure, yeah, if it's a closure it works like this. However, if it's a mutable variable, then we might not have these values anywhere yet. So that actually happens later. So then we actually skip those. So if we're looking up at the current depth, so actually maybe it is better to use a type here. I'm gonna say this is a type, which is some kind of enum. So this would be like outer and I guess mutable. I guess we could keep depth to make that work as well. But this would be outer. And this would be mutable. And we can rename you to mutable. Or not. Excuse me. All right. Okay, so now when we do this, this would be main. And whoop. Almost spilled out a lot of stuff. Yeah, hang on. Let's finish this thought here first. So this would be instructions. Okay, now here is like, well, we have the destination, well, or we're going through everything, but the thing is, I don't think we actually do this at all if it's the main thread, because the main thread doesn't have any closure variables. It doesn't reference, there is no outer scope. So it doesn't actually reference anything from the outer scope. So this would actually never happen here. We don't actually populate anything. So this is the only thing that's happening. We're allocating enough space in the closure for the main thread to accommodate for the local variables. And then we set the closure ref to that, so that then later that can be used to... Actually, you know what? We don't really need a closure ref either, because we can just set stack. We can just set, so init add stack 3, right? Actually, this would be abs, and then dereference true, I think. Yeah. So we're just setting this. Actually, do we dereference here? No, I don't think so. I'm not sure actually, but we're setting stack 3, which always is the closure for the current thread, to the thing. Okay, so this would be like set stack 3 equals that. Right. And in that case, we actually don't really need... Well, we do need a closure context, but actually what we need... Okay, we need the index, and we need how many closure items there are. But we don't need those refs. We don't need the refs. So we could make this into a main closure context. It's kind of convoluted here, but we don't actually need these refs here. We just need an index actually. Okay. Because the closure is from the frame, right? Or the items, the number of items. And that this would really just happen, like we cannot know where this is happening. But whatever, let's just do that. Create main closure. Okay. Good. And this is still 4 here. Yeah. Cool. And then now we don't actually need this. I'm gonna remove that. Okay, but now stack S3. So we don't actually need, well, we need to create a space for it. I'll set it to 0 to start with. And then after, this thing is then setting that to R. and this is going to happen after forward standard IO. So this would happen insert index +1. Okay. Now let's go and see what the things are doing. So first we're doing this. We get all the things on the stack. Fork? What the hell is this? Oh. Okay, so it wasn't +1. I was just kidding. Or we're supposed to call this first. Whatever. This should be fine. Okay, there we go. Now we got alloc 1. So that's how many things we need on the closure or on the local variables. And we set S3 to that. So now this is pointing to the closure. And here we're now using that space. So so if we look at the closure now, we look at the heap. So here's the closure here. So null means yeah, whatever. 4 is it's set to void, and that's fine. Now we're using that to set to 5. So if we step here, we get an error. Okay. Okay, so it might be because we're dereferencing it. So we're setting. Okay, maybe we don't dereference then. But it's already dereferenced. And we don't have like an undereference. So I'm gonna say wait, you are a location. There should be a dereference function here. Dereference. What the hell? Okay, that was weird. Okay, maybe I went somewhere else. Anyway. Let's do this. Because the thing is, this is kind of weird because the closure pointer works differently. It's kind of automatically dereferencing. And if we dereference again, that will, I think, go even beyond. So let's try this again. Okay, there we go. Now look at the heap. So there we go. Now it's set that to 5. Whoops. And then we create a closure in there. Right, this is the closure for the fork. I'm just gonna skip through here a little bit. Alright, so now we're doing that. So now we're seeing that, okay, well, the fork or the closure for the inner thread or for the thread here is 5. So here's that. And we can see that it's actually a copy of the original. So that means if we try to change it, it's gonna be, you know, like we're changing the copy. So basically, you know, we're referencing it fine here, but if we, let's say we have a block here. Okay, this should still run fine, yeah. And then we reassign here, although this doesn't work now because we don't support this right now. But that was weird. We get like a seg fault. Okay, I'm not sure why we get a seg fault here, but because if we do this, we get an error that says that assign is not yet supported, which is over here. So this is not actually like an assign operation, or well, it's a declaring the variable, and then we have the initializer expression here. But here is an assignment operation where you it's kind of like a reassignment. This is only valid in the context of assigning a mutable variable. So we're assigning x to something else. And then we also have like plus equals, but we don't support that right now either. Add assign not yet support. So, but why was it like an issue in the block? So there's like a bug then in the parser that can't handle this right here. Interesting. Let's do actually print AST. Okay, so it does parse it. Wait. So where is this going wrong? It's looking at diagnostics, and that's a seg fault. Diagnostics from where? Run script 189. Oh man, it feels like I've been forever since I wasn't here. Alright, so enable IR. Okay. So it's like trying to process the result from this here. Interesting. Colon set RNU. I don't want that. There's a reason why I don't see the numbers. I don't like this. Wait, how do you return it off? God damn it. Okay, there we go. No, because I think it's like it's distracting. Like I don't want that visual noise happening all the time. Okay. So okay, where was the issue? 429. All right, so accessing this info, right? Oops. So basically in here. And I guess we can say Ronic log. I think it's evaluator. Or is it? Or runner? No. Oh, verbose. No? What's happening? Why is this happening? Let's do this. Okay, so I guess it could technically happen if something goes wrong straight away, I guess, before we even log anything out. This part here. Right, something goes wrong in the compilation. We return this diagnostics here. Okay, are we also deinitializing an arena? Yes, we are. Is that arena used to store the diagnostics is the next question. But that's weird because this is like the first time this error is happening in this way. Maybe, I'm not sure actually. Maybe it's like one of the things gets... Yeah, so we just do that. Compiler, self-allocator. Right. So that is just self-allocated. It's not even using an arena or anything. Unless this is... This is using an arena allocator. Okay. Right. So this is the issue. The whole runner. Right. So we want this to be copied and also these diagnostics, like the message, everything here is like in the arena. I mean, I guess we could return the arena here and deinitialize the result. Makes sense. But then we need to make this into a struct. Or include the arena. Actually, you know what? No. No, we'll keep it like this. The only place we need the arena is in here. And then we add a deinitialize function here. Which will switch on self if it's error. We call that this doesn't do anything. Alright, and so we don't actually defer arena there. And what we do is we say we pass the arena here. There we go. Hello, abbreviated. The scripting language is going on still, yes. It is. Okay, yeah, same thing here. There we go, and now we're gonna get leaks unless we deinitialize the result. All right. Although those leaks doesn't really matter, but there we go. Now we can see the thing. Okay, cool. The scope of the language is not really that well defined, but it's basically gonna be, it's not gonna be all of Bash, because that's insane. What it's gonna be is like a subset of Bash features that is gonna satisfy my own personal use of Bash, which is not very deep at all. I'm trying to gather the requirements in here, mvp.rn, but it's not. I'm basically adding things here as I add them to the language. This doesn't integrate with the game. I mean, it doesn't run like the game doesn't run like Runic code or anything like that. This is like a separate project. But I will get back to the game eventually. But yeah. I mean, most things are in place. I just want basically functions. But the basic features, like what I think once I've gotten to the point where it kind of basically works, you know, all the basic stuff, then I will be probably happy with this and probably add maybe a thing here and there, but then basically this project would be done. So we're not. It's not long now, but I will try to get like I'm also trying to like get inspiration for the game as well to get back into it. I'm thinking about it more and more because I think I'm kind of lacking right now in kind of like what I want to have like include in the game and stuff. So yeah, but and then maybe do some kind of like every other stream we get back in the game, or some stream we get back into the game, and it's gonna be a little bit of startup. All right. See you later. Let's see. Okay, right. So now we actually get this error here without crashing and burning. Great. And we get the correct error. So this is what I was expecting before to get. All right. Now, let's see. Can we now make this work? So basically, so this works. So it's kind of like we have the basic. Oh, we're leaking again. Wait, why is this? Yeah, it's the arena. Okay. Did I forget something? Because we're initializing everything here. Okay, there's a lot of things getting leaked here. Let's see. Yeah, the compiler. But why is it leaked though? Why? Is it because... No? No, because even if something goes wrong here, we're calling the initialize on results. Although that would be an error if... Yeah, I'm gonna do this. Wait, why? Yeah. I'm gonna do that for now. I don't think that will do any difference here now. Why are we getting these leaks here now? Oh, okay. It's because we're not returning an error. Right. Okay. So, okay, yeah. So at the end, we should get a success. It's just that, okay, I see. If we get down here, we have successfully done the thing. So here we want to do arena to initialize. Because the success is just going to be like a literal value. So, Okay. Wait, this is the same thing. We'll do that after that. Okay. I mean, we should yeah, whatever. There we go. Okay. So, okay. We said x equals 5. We can reference it inside the block. If we try to modify it from within the block, we are getting an error because the sign operator is not yet supported. Okay, but that's not really what we want to test here. This is more what we want to test. So what we want to support now is the assign operator. Okay, so what should actually happen here? I mean, it's kind of basic, actually. I mean, we're just setting x. We're looking up x, and we're setting it to this expression here. Right? And that is like a normal operation in the IR. So compile, I think it's binary. We have assign is not actually in here. So we'll do like assign. And right, that's the operation. And so we have like left and right. Now the left should, like in the case of assignment, left should always be like an identifier, or so, like it's you can't, because you can't assign to, whoops, what the hell? Oh, I enabled caps lock for some reason. There we go. You cannot assign, let's say you assign this to 3. This should be an error already in the parser, I think. Expected reference before assignment operator actual call. Yeah. So this actually is caught there in the parser already. So we can kind of assume that whatever is on the left hand side is some kind of thing that you can assign. Actually, if you make this binary operator assignment sorted, okay, so we get both of those. But this should also be an error, a different error. Okay. Man, I hate that auto formatting from Vim. Okay. So the left hand side is it really an expression? I guess it is. Okay. Let's get that. And then I guess we also have the right hand side. And then we just add a set instruction. And that will be location is left. So I think we can assume it's going to be a location. If it's a value, that doesn't make sense in this scenario. Right hand side is then right source. And I think that's it. Right, and the expression of this would be, what does this actually like evaluate into then? I mean, I guess it would be left. Dereferenced or something? I don't know. Or we could just say void. No. Okay, I don't know. Let's do... this. Okay. So will this just work now? Is the question. No. Of course not. Could not dereference value of type u integer. Let's see here what's going on. So C0 is equal to 5. We create a closure for the inner thread. We set that to that. We create the fork. We're creating the string. Why is it at 8 now? That's weird. Okay, but that will set second item to C plus 0, which should be 5. So 9, that's the heap, or I mean, yeah, that's the closure. A is the string, which has 2 elements. The first is read only, and the second is just 5. Is it because it's trying to dereference this? I think. So in here it... No? That's weird. I thought we would get the error there. Oh, I see. Okay, now we're at the second part. So the first part is fine. So now we're at this part. Okay. Okay. Now we're at this part. So we're creating the arithmetic results ref. We're setting that to C plus 0 plus 5. So what is C plus 0? I think the problem here is that this is dereferenced. That's the issue. Yeah. So now it should be an issue. Now it should be error. Or not? Okay. What the hell? Or maybe now? Okay, there we go. That's the issue. So it's like when it's trying to set X back. The problem is, though, okay, I mean, we could try this. We could try compile identifier. So, no, look up. We declare, no, not compile identifier. It's gonna be compile binding, yeah. And then over here somewhere. So actually, yeah, we get this location. And we're declaring here. I think we don't want this to be dereferenced. I don't know. It's kind of weird. It depends. Like if it's a closure. Do it, or is it the same? Of course, this won't work. That is equal to 5. Why is this set to 8 now? I'm confused about that. It's like skipping over 4. Goes straight down to 8. Not sure why. Okay, now we can see here, we're setting R to, or we set the first, this is the closure of the inner thread, and now this is not 5 anymore. This is the heap address 8, or the address 8 instead. So, because it was not dereferenced anymore. Which is probably correct, because we want it to be a pointer, because we want to be able to mutate it from within the thread, I think. Even though there could be issues with that, like, I mean, what's gonna happen here? Like, let's say you have like this, and you have like sleep 2. And then maybe this happens in the background. You have like something like this. After 2, X is increased by 5. I mean, I guess it makes sense though. You just have to, I guess you just have to kind of know what's going on, maybe. Okay, but anyway, without it being a pointer, it can't be modified from within. Okay, what's happening here? We're setting that to our... Okay, we're allocating the string. Right, and now we're setting that to that, so E8. So here's the main thread's closure. It's populated by something, the X is 5. Here's the inner thread's closure, it points to this. So it's like a reference here to this. And then here's the string. With 2 elements. The first is that. So now we're setting this to C plus 0. C is 9. 0 plus 0 is 9. So it will set it to this, but it's dereferenced. So I guess it would end up being 5. No? Okay, so it's the same. Well, I guess it's not dereferenced. Anyway. And then we pop, okay. Push that, push 1. Okay, exec. Right, okay, this is the issue now. I think this will crash because we encounter an address and we assume it's like a value slice or whatever we call it. Yeah. Like this kind of string rope here. Although it is though. But then the inner thing is a pointer. Yeah. Okay, this is interesting. Because it's like when we use like a constant, it was kind of simple because we could just use the value directly, sort of. Now it's like a reference to something, so I guess we have to have like special handling of that. So what is happening here? We have a reference. But in the value, it's just an address. Like in the instructions, it's just an address. Wait. No, it's not. Not in the instruction. It's in the closure. It's a pointer to the closure. We dereference it to get another pointer. That. It's kind of what I'm trying to figure out now. It feels like the generic handling of like these, the referenced variables now. And my keyboard keeps messing up. I don't know what's going on. It's like there's something going on with the electricity or something. The keyboard is like randomly disconnecting, and then you have to unplug and plug it in again to, and now it's like it's annoying because it worked fine for like a long time, and then all of a sudden it stops working. Okay. But I feel like we solved the issue by we have a space for the variable, and we can refer to it as a pointer. But the problem now is like, how do we deal with this? So if we go and look at how this works, we go to the evaluator, we go to, I mean, we could go to like the exec. And here are all the arguments that we're going through. And what we're doing is that we are materializing a string for each argument, which basically just goes in, looks at what is the argument value that we have, and tries to turn it into a string. So either it could be just a little literal string, then we just use that. It could also be, here we have kind of like a rope where we have a slice that has, so, well, actually, is this even used anymore? I don't remember. I don't think so. No? It's actually just right. So what we return is actually just this thing here, which in the end, yeah, it's stored on the heap. So it's just going to be an address actually to the heap. Why isn't it going back to the thing? All right. Here. So I don't know why we have inline here, but so address. So if we get an address, we're kind of always assuming it's going to be like a rope type structure. And how it is defined is that it's just it's a pointer, and where it points to has at least two elements. So the first element is always going to be the length of the value. So we're looking at that thing on the heap and we're assuming it's an integer. So kind of how the heap works is, and all the memory here works, is that we have this value type that is what everything is stored as. So it's not really, it's not like we have just a stream of bytes as memory. The memory is actually consisting of a list of these things. So we have like built-in kind of like type in the memory here. So, but the first thing is always assumed to be an integer, which is the length of the slice, and then, or the rope or whatever. And then we go through each one, and that is kind of magically, recursively turned into a string with using recursively calling materialize string on the thing that we get. So that is how that works. So every subsequent element is a value that then gets turned into a string. And then we have like a writer that we write into to like create a string in the end. But now it's like we can have a pointer that points to basically anything. It could be a pointer that points to a float or a U integer itself. So that is the issue now. We can't assume that it's pointing to a slice on the heap. So that is my issue here now, is like, are we solving this in the compiler somehow? Or how are we solving this? Are we doing like a string conversion in the compiler, or are we compiling instructions to turn this into a string through instructions instead? Because this is a kind of like a magical evaluating things, and we're coercing things to strings directly in like the eval in the interpreter. Because we can't. Yeah, the thing is, we get an address. No, but then we should actually dereference at that point. Yeah, so the way things are right now is that the issue now is over here. Okay, the issue is over here. But I'm thinking when we compile and we see that, okay, well, this is used like this, so we should dereference it at this point. Because we know it's supposed to be a pointer, because we know that it's supposed to go, it's a reference. So we should dereference it at this stage. Because we're not setting it. No, we should, yeah, okay. It's kind of complicated how this works, because the pointers are like, I have like different types of pointers, and they don't all work like the same. So yeah, it's a mess. But it was kind of necessary to be able to like work with the closures. So the closure pointer works differently. That is like automatically dereferenced. Where are we? What are we doing? This would be, I mean, it's compile identifier really. So this one simply returns the lookup here. The problem is now, how do we know that we're supposed to dereference this? That's the issue. Do we need some more context? When compiling stuff? So this is also an identifier. The thing is, this works for y, but not for x. And so it works for y because what we store here is not a reference, it's the actual value itself. So when we reference y here, we actually just put 3 in there. Although technically we do create a closure here and do all that, even though this is like a comp time known constant. But yeah, but we do that. Because you could technically reference to runtime only known stuff. Like you could do this x, and now we do need it to be a closure. But anyway, actually, no. Yeah, so this works because this becomes a thing on the closure that's set to 3. Right, and then you refer to that, which will just be a 3. Oh my god, I feel like I'm running in circles here. Like, what do we need for this to work? It's like finding the correct puzzle piece to a pretty complicated puzzle where you can't sometimes you can't really see every angle at once. It's like a multi-dimensional puzzle piece you need to fit in there. Okay. Like, it shouldn't be so hard. What if we did this? I'm just gonna do this to see. What are you? Unsupported binary expression? So is it x plus 5 that's unsupported? Okay, well, I guess we'll start with that. Actually, no, we should have that. Like add is... Or did I remove the thing? No, we have assign. We have add. So what the hell were you talking about? Unsupported. So it's like going down here. No. Wait, did I read everything? Error evaluating. It just says unsupported binary expression. Where does it get that? Because it's not this error, because then we would see more messages. Or is it the evaluator? Oh, I think it's because when we do this plus 5, since this is a reference, it doesn't work. It only works with numbers. I see. Okay. So that's happening here in the evaluator. Yeah. Okay. Yeah. All right. I'm just trying to figure out. I mean, we could just brute force it in here right now, but I'm just trying to figure out a good pattern for this. Because yeah, this would be a pointer at this stage. I mean, maybe it should be part of the compilation, like instead of making this be a arithmetic operation only, it should be two things. Like we're compiling the identifier, and then we have to load the value at the location as well, and then plug that into the arithmetic operation. So actually, no, not compiler. Compile. Well, it's not gonna be in here. Maybe it's like when we do the lookup and we see that, okay, this is actually referring to, well, okay, anytime we're doing a lookup, because all all identifiers are bound right now, they are actually bound to somewhere in the closure. So if we find a local binding, instead of just returning the result, do we have to, like, we could do a check, okay, are you, no, you are a closure pointer. Well, we don't know if you're a closure pointer, or you could also be a constant, actually. I was just joking. It could be a constant, yeah. Then it's not stored on the closure, actually. But let's say we check it and see, well, okay, is this a reference to a thing? Like, what is X? Wait, what is that actually like compiled to here? C plus 0, right? that is x. X is c plus 0. So it is the closure. And that kind of tells us that, I mean, either it's a reference to a constant, it could be like from the outer closure, or it could be a reference to a mutable in the current scope. And so we set it. Okay, now here. What we need to do is, instead of saying c plus 0 plus 5, it's gonna be, I think, like dereferencing this to make it work. I just don't see a clear pattern here for this. That's the issue. Could be one of those things I need to sleep on to see, to kind of go in with new energy, pick a solution, implement it. Well, actually, you know what? We have this. It's mutable here. And actually, this is weird because if this is always set to true, which is actually not the case. Because if we're referring to a constant, we shouldn't actually be able to mutate this. So this has to depend on if we are mutable or not. So actually, let's add this over here. Right? And we'll do that. No, we don't have local binding. We have is mutable, right? No. Yeah. Actually, okay, yeah, this would depend on the outer value that we don't actually have yet. So actually we need to kind of find the original, actually, but we do have this here. This is the source binding. So this is the kind of the original binding here. And we can use that to inherit the mutability. Okay. There we go. And same thing here. Okay, what can we do with that? Is the question now. So if it's mutable, it kind of means it's going to be a reference. Right? It's always going to be a reference, I think. Unless it's the original binding. No, but that should point to the closure then. Yeah, that's also a pointer. Yes. Although it's a closure pointer, so it's actually not the same. God damn it. But okay, let's do. Okay, how can we fix this now? So if it's mutable, we know then that it's a location, and we like dereference it then, or it's also over here. It's like no, that's dereferenced already. Okay, whatever. If it's mutable, we will return this. Man, this is not great. See, now this is a dereference instead of not dereference, so it should work. Okay, so we got actually we did get through one more step there. So the arithmetic worked, and you can see that we're storing it in this, which is over here 10, so that is correct. But then when we're setting x now to the result, it's not correct. So this is wrong. It's like when we're setting it, we shouldn't use dereference. Actually, we should. If it's a point. Oh my god. No, not in this case, because this case C plus 0 actually doesn't point to like a place on the heap. Well, I mean the dereference. No. It's not like a two-layered pointer, it's a one-layer pointer. Oh my god. It would have worked if we would, let's say we would allocate x itself and then set the closure to point to that place. That would have worked. Maybe that's what we need to do actually. But that seems unnecessary. So it's like when we do, let's say, compile binding, and if it's mutable, we declare it, we set it. It's like is this location, what is this location? Is it always going to be closure? Yes. So we don't need to worry about R here. Although we could worry about R from here though. That's the thing. Because what I want to do is I want to allocate. So we need to do this here. Okay. And then what I want to do is I want to allocate one thing on the stack, and we want to set we want to set that to be the result. And then we want to set the closure location to be R. Which is pointing to the heap where the value is stored. Yeah, so we're using the closure as kind of like, how would you say it? Like it's used as like a way to be able to access a closure relative identifier on the heap. Same way as stack frame is used, like stack address, relative stack addresses is used relative to the stack frame. So the compiler would know, like, okay, well, X means this, Y means this, like stack frame plus 0, stack frame plus 4. So those like relative addresses are comp time known. The same is true here. So the closure pointer address is runtime known. However, the relative address from that pointer is comp time known. So that's how we could reference these values on the heap now. Right. So we have the result. We store it on the heap. We set the heap location with the reference to the result. And then we also set the and then we set the closure location to be the pointer to where we store it on heap. Yeah. All right. this would be from location. Okay. Now let's see what this gives us. Whoops. Please. Okay. Okay, that's the closure. Here we can see that, okay, now we're allocating the thing on the heap. And we're setting that to 5. And we're setting closure item number 0 to the pointer. So if we look at the heap now, 8. What? Okay, that is not correct. It should not be at 0. What the hell? Oh, the closure hasn't updated yet. Wait, what? It should have. Hang on. Yeah. Wait, why is that why is that 0? Okay, alloc 1 is stored at 0, 0. That does not make sense. Oh, it does make sense. Okay, sorry. It does make sense because, yeah, the starting address of the heap depends on the read-only data size. So actually, it does make sense because we don't have any read-only data right now. Right. So it does make total sense. Okay. Yeah. Alloc 1. Now that should be 1. Yeah. And then set 1 to 5. So if we look at the heap now, we should see we have, so the closure is empty, but it has 1 space, and then now we've allocated X to be 5 there, and now we should be setting the first one to point to 1. Okay. So this all looks good right now, okay? It's creating a ref. Now let's look at this. So we have arithmetic, this ref, which is SF plus 4, which is over here. This is void. Oh yeah, because we're setting it now. So it's setting this to be equal to C plus 0, which is over here, dereferenced, which means we should take the pointer inside, grab whatever value is there, plus 5. Okay, that should all be fine, but it is not. Interesting. So that would be evaluator, and so it's kind of like this doesn't actually resolve to a good thing. So it's a location, yes. It is dereferenced, yes. And the thing that it is over here. It's we can make it into an address, and then we're dereferencing that should give us closure plus 0. So that should give us the address to the closure. And we dereference that. That should give us the pointer to... Okay, so we don't actually have any special handling of closures here. Actually. So we're running into the same issue here of needing a double dereference. Again. But there's a difference between resolve location and resolve value source. I think. No, it's not. So this just gives us the address, which should just point to the closure. And then we also want to dereference it. Which does that. This is an address where we just get the heap there. So that should now result in the pointer to the thing. Okay, so if we go to like set, for example, it's going to be different because here, the closure, we get the address. Well, yeah, destination. Yeah, okay. This is the stack. Yeah, this is the closure address and the address. So now we get the address of the thing. So, but then if we dereference, we actually dereference this address. So wait. Yeah, that's the address, and we get the pointer to that address. That we get the value in that address. So actually, we already dereference. This is like dereferencing here. So this is double dereference. This is the thing. Like, it behaves differently depending on where in the code we are. That's the issue. I just need to figure out how do I want this to work in all circumstances. It shouldn't be different depending on circumstance. It's like if you're trying to set the closure directly, I guess you're never supposed to do that, actually. So it's like if we resolve a location which is the closure, we should actually automatically dereference it. If it's a location, we do this, or closure, I mean. I mean, we could also do like return sole location. No, resolve location. But that doesn't work. No, that doesn't work. Actually. God damn it. All right. I think what we'll do is I'm gonna write this down. Always dereference closure. You're not supposed to change where closure entries point to. All right. So I'll write that down. I need to go now, so yeah, we'll continue this some other time. Maybe tomorrow, we'll see. But yeah, that's gonna be it for this time. So thank you very much for watching, and hope you have a nice day, and I'll see you later. Bye bye.